Throughout human history, people have gazed at the night sky in wonder. Ancient civilizations charted the stars, created myths about the constellations, and searched for meaning in the shifting patterns above. For thousands of years, our ancestors used the heavens as calendars, navigational tools, and even spiritual guides. But behind all that wonder was always a deeper question. What is the universe, and how did it begin? For most of history, those questions remained unanswered, confined to philosophy and imagination. It wasn't until the last century that technology allowed us to see beyond the reach of our own eyes. Telescopes on Earth opened the door, and then the Hubble Space Telescope gave us a front-row seat to the cosmos. Yet, as groundbreaking as Hubble was, its successor, the James Webb Space Telescope, or JWST, has taken that mission even further, unveiling details so astonishing that they are rewriting the textbooks of astrophysics. The James Webb Space Telescope has revealed discoveries so profound that they could change the way we think about the cosmos itself. These are not just pretty pictures, they are windows into the earliest chapters of existence, moments after the birth of the universe. The telescope's incredible ability to capture light that has traveled across billions of years is giving scientists answers to questions that once seemed unanswerable. So, what exactly has Webb uncovered, and why are scientists calling its findings revolutionary? Today, we'll embark on a journey across space and time, exploring these breathtaking discoveries and what they mean for our understanding of reality. And if you're passionate about learning more about the universe and want to stay updated with discoveries from beyond Earth, don't forget to subscribe to our channel, hit that like button, and turn on notifications. Imagine stepping into a time machine that could take you back billions of years. That is, in essence, what the James Webb Space Telescope provides. Unlike any telescope before it, Webb specializes in observing infrared light, the faint, stretched-out glow emitted by some of the most distant objects in the universe. Because the universe is constantly expanding, light from early galaxies is redshifted, meaning its wavelength stretches as it travels. By the time it reaches us, the light that once shone in visible colors has been shifted into the infrared spectrum. This is where Webb's design is unparalleled. With its giant gold-coated mirror spanning 6.5 meters, its location nearly 1.5 million kilometers away from Earth at the second Lagrange point, and its ultra-sensitive infrared instruments, Webb can detect this ancient light with precision. It works like a cosmic archaeologist, digging back through layers of time to reveal the universe's origins. The result has been nothing short of astonishing. Astronomers using Webb have captured not only dazzling images but also unprecedented data about the composition, structure, and history of the cosmos. The telescope has turned what was once invisible into something we can finally study. One of Webb's most intriguing targets is MAX 0647 JD, first identified by Hubble about a decade ago. This galaxy, or what appears to be one, sits at an almost unimaginable distance. With the help of gravitational lensing, where the gravity of a massive cluster of galaxies bends and magnifies light behind it, scientists can observe MAX 0647 JD in far greater detail than ever before. Yet the mystery remains. Are we seeing a single galaxy, or is it actually two separate galaxies lying so close together that they look like one? This is more than a matter of classification, it's a glimpse into how galaxies formed and evolved in the earliest days of the universe. Webb's superior resolution and sensitivity could finally provide answers, helping scientists trace back the steps of galaxy formation. But MAX 0647 JD is just one piece of the puzzle. Webb's ability to peer deeper into time has shattered previous records for the oldest galaxies ever observed. Take Glass Z12, for example. This galaxy existed a mere 350 million years after the Big Bang, making it more than 13 billion years old. Before Webb, the previous record holder was GNZ11, spotted by Hubble and dating back about 400 million years after the universe's beginning. Now, Webb has pushed the frontier even further. One of the most jaw-dropping candidates is CEERS 93316, which may date to just 250 million years after the Big Bang. Its redshift, measured at 16.7, places it firmly in the earliest stages of cosmic history. If confirmed, this discovery would not only extend our timeline of galaxy formation but also challenge long-standing theories about how quickly stars and galaxies formed in the aftermath of the Big Bang. Think about that for a moment. Light from CEERS 93316 has been traveling for more than 13.5 billion years just to reach Webb's mirror. When we look at it today, we are literally seeing the universe as it was at the dawn of time. Another extraordinary find is Abell 2744 Y1, a galaxy whose light has traveled 13 billion years to reach Earth. Despite being 50 times smaller than the Milky Way, Abell 2744 Y1 produces stars at a rate 10 times faster than our galaxy does today. This furious pace of star formation reflects the turbulent environment of the early universe, when galaxies were smaller, more chaotic, and brimming with raw materials. Scientists are fascinated by this galaxy because it demonstrates just how differently the early cosmos behaved compared to the universe we see now. Understanding these early bursts of star formation helps astrophysicists piece together the story of how galaxies matured into the massive spirals and ellipticals we know today. As we marvel at Webb's discoveries, it's important to reflect on the sheer scale of the universe itself. The observable universe has a radius of about 46 billion light-years. That's the part we can see, but it may be only a fraction of the whole. The true universe could extend far beyond our observational horizon, possibly trillions of light-years across. Some theories suggest that the Big Bang was not the beginning of everything, but merely the beginning of the universe as we know it. According to the concept of cosmic inflation, the universe underwent a rapid, exponential expansion even before the hot Big Bang. If this is correct, then our observable universe could be just a small bubble in a much larger cosmic sea. And if eternal inflation is possible, then countless other universes may exist, each with its own physical laws. This leads to a tantalizing thought. Are we truly alone in the cosmos, or are there other universes out there where life has also taken root? While Webb cannot directly confirm such possibilities, its discoveries are helping us understand the broader framework of cosmic evolution. Perhaps the most iconic distant galaxy observed so far is GNZ 11. Located an incredible 32 billion light-years away when accounting for the expansion of space, GNZ 11 shows us the universe as it was when it was only 3% of its current age. The light from GNZ 11 began its journey when the universe was still in its infancy. This galaxy marks the limits of our current observational capabilities. Beyond it lies the surface of last scattering, the point when the first photons were released after the recombination of matter and radiation. In other words, GNZ 11 represents the very edge of what we can currently see. It is a cosmic horizon that reminds us both of how far we've come, and how much remains hidden. The James Webb Space Telescope has not only provided breathtaking images but has also transformed our understanding of the universe's earliest days. It has given us evidence that galaxies formed earlier and faster than once believed, and it has pushed the boundaries of human observation farther than ever before. These discoveries remind us that we are just a small part of a much larger story. The universe is vast, ancient, and filled with mysteries waiting to be uncovered. Every new image and dataset from Webb is a step closer to answering questions about where we came from, how galaxies like our Milky Way formed, and perhaps even whether life exists elsewhere in the cosmos. So, what do you think about these groundbreaking revelations? Could Webb's discoveries fundamentally change how we see our place in the universe? Share your thoughts in the comments. We'd love to hear your perspective. And remember, by liking this video and subscribing to our channel, you're supporting our mission to bring the wonders of space closer to you. Thank you for watching, and until next time, keep looking up, because the universe always has more to reveal.